Every year, the UK spends over £55 billion on long-term healthcare. With a combination of an ageing population and a shortage of carers, there's an increased pressure now placed on healthcare workers and family members to provide the necessary care for patients. By adding robotic assistance in care homes and hospitals, we can help minimise the stress on carers, reduce the overall cost of care, and provide increased independence to users. The robots in these environments will face several challenges, such as providing personalised care to multiple users, adapting to unstructured living spaces, and quickly reacting to changes by predicting future behaviours and independently forming plans of actions to complete their goal. We've addressed these challenges by combining a biologically inspired episodic memory network for continuous learning and recall of experience, identification of users through facial recognition, and object recognition. A key feature of any cognitive system is the ability to learn cumulatively. In humans, episodic memory allows for the storage and recall of personal experience, making it possible to imagine future scenarios by recalling actions from similar situations in the past and applying it to the present. By combining episodic memory and robotics, it's possible for the robots to learn and develop new skills over time through their experience with users, which are then recalled later in order to perform goal-directed planning. The robot's experiences are encoded into an auto-associative neural network and recalled using multimodal partial cues gathered from the environment. These cues can range from visually detected objects, seeing a familiar face, or hearing a particular word. Here the robot gains experience by interacting with different shapes while attempting to build a tower. Because of the experience gained from this, the next time the robot views these objects, the related object hub networks are activated, creating a partial cue that can be used to recall the experience to form a plan. The learned actions can then be applied to more advanced assembly tasks. In addition to the recognized objects, a social element is now added to the memory to allow the robot to recall experiences that are most relevant given the current social context, such as in the following video where the user is detected holding incorrect medication.
Hello, Penny. You are taking the incorrect medication. Please take medication 20 instead.
In the video, the conflict of what was seen versus what the robot predicted based on its experience caused the robot to alert the user to a potentially dangerous action and correct them. The addition of facial recognition to the current system therefore creates a more user-centric assistance, allowing the robot to adapt action plans to suit a specific user's needs. As not all actions will be user-specific, such as fetching objects or turning off a light, it's also possible to transfer general experiences between users for everyday assistance. This is particularly useful as the user is new and not recognized by the robot, as it's still able to provide assistance and can later customize those actions based on the user. We can also now go beyond the physical space of the robot by using phone calls to gather additional cues. If the robot detects a risk to life, it can call a human and use their command as a cue. If the human calls the robot to give it a particular command, that can be used as a cue. And if the robot cannot find a plan from what it can see in its environment, it can call for help and ask the human to provide it a goal, which is also another cue.